Good morning, children. Welcome to your chemistry online class. Last class, we have discussed about Rutherford's model of atom. There we have seen certain limitations. He couldn't explain the stability of an atom. So, what will happen next? The next model came. So, this model is known as Bohr's model of atom. So, in today's class, we are going to discuss about Bohr's model of atom. So, we'll see what is Bohr's model of atom and what are his postulates and what are the energy shells in an atom. So, let's begin.
So children, we will see what is Bohr models of atom. Bohr models of atom. What will be there for Bohr's model? So according to Bohr's model, electrons revolve around the nucleus in circular path. The circular path is called orbits or energy shells or energy level. For example, this is an outline of Bohr's model of atom. Here he stated that atom consists of a positive charged particle center of the atom called nucleus. All the protons and neutrons are exist in the nucleus, hence protons having positive charge, hence nucleus is positively charged. And he stated that electrons are revolved around the nucleus in circular path. You can see here certain circular path. The circular paths are known as energy levels or shells. This is his first postulate or first identification. Rutherford is a physicist and he was a student. He worked in Rutherford's laboratory and he identified the model of atom and he awarded Nobel Prize for his achievement of the structure of atom. So this was his first observation. So electrons are revolved around the nucleus in a circular path. The circular path called orbits or energy shells or energy level. Next postulate. An atom may have infinite number of orbits. An atom having infinite number of orbits. Only few orbits contains electron in them. These orbits are known as discrete orbitals. Electrons present in discrete orbits have stable energy. Hence, electrons do not lose energy during the revolution, due to which electrons do not fall in nucleus. Hence, Bohr's model explains stability of atom. That is, we know if we take these energy levels, every electron is having a certain energy level and they will not they are revolving around the nucleus. We know one of the major drawback of Rutherford model is he couldn't explain the stability of atom. He said that electrons are revolving around the nucleus in orbits, but he could not explain how the electrons are revolving. We know that we already discussed. Bohr explained this. He said that electrons are revolving in a certain orbits. For particular orbit, particular electrons, there will be particular orbits. So if some electrons are here, some electrons are here, but each and every electron is having a particular orbit. So while this energy level is known as discrete energy level, while revolving around this, they are not losing any kind of energy. For the revolution, they are not using or any energy. So he could explain the stability of atom. So the next one is in Bohr's model, energy electron is stable. In the Bohr's model, energy of electron is stable. It is not vary. But sometimes it will vary. How it will vary? If electron jumps from higher orbital to lower orbital or from lower orbital to higher orbital. In such case, energy of electron changes. For example, if you see this image, sometimes an electron from this shell or this energy level will jump to here. For jumping from here to here, it required some energy. Sometimes the energy will change, or from here to here, if an electron jump from this shell to this shell, it should emit some kind of energy. This energy is known as represented by the letter h nu. These are things you will study in your higher classes. This is the next postulate. Sometimes their energy may change. How their energy may change? If it jump from one shell to another shell. This is the next postulate. The next one. Orbits or shells are represented by alphabets. We know if you observe this image, you can see that some numbers are here 1, 2, 3, 4 and KLM. Each orbits were represented by either number or shells. Usually we are using the alphabets, that is K shell, L shell, M shell and N shell. So every electrons are arranging in these shells. So the first shell near to the nucleus is known as K shell. The second shell is L shell. The third shell is M shell and fourth shell is N shell. And the center, which consists of the positively charged nucleus. And the number of protons and number of electrons are same. Hence atom is neutral. That also we have seen in Thomson model of atom. This is about the Bohr's model of atom. So we will see how many electrons can accommodate in each shell. How many electrons can accommodate in K shell, L shell? Is all are equal? Or we'll see how many electrons can accommodate in each shell. Okay.
Hello children. We know electrons are arranged in atom in shells. So, we'll see how electrons are arranged in each shells and what will the number of electrons in each shell. So, we'll see. And if we take the structure of atom, we know according to Bohr's model, in the center there is a positively charged nucleus. Nucleus contains protons and neutrons. And we know electrons are arranged in each shells. So there are 4 types of shells. There are so many shells, but we are studying about 4 types of shell. Those are K shell, L shell, M shell and N shell. So the first shell is known as K shell, second shell is L shell, third shell is M shell and fourth shell is N shell. How many electrons can accommodate in K shell? Do you know? We will calculate. There is a formula to calculate number of electrons in each shell. That formula is 2n square. Here n is an integer. N may be 1, 2, 3, 4. What is this 1, 2, 3, 4? If we take the nucleus and each shell from nucleus, the first shell is K shell. So n equal to 1 for K shell. N is equal to 2 for L shell. N is equal to 3 for M shell. So similar manner, we can calculate how many electrons will be there in whatever number of shells. So we'll see how many electrons can accommodate in K shell. So we know here N is equal to 1 for K shell. So instead of N, we can put 1. So 2 into 1 square. 2 into 1 square. 1 square. 1 square is 1 into 1. So 1. 2 into 1 is 2. So totally 2 electrons can accommodate in K shell. So how can we represent that? Either we can represent electron by cross mark or by dot. So 2 electrons will be there in K shell. So how many electrons will be there in L shell? So instead of n, we can put 2 for L shell. So 2 into 2 square. What is 2 square? 2 square is 4. So 4 into 2 is 8. So we can accommodate 8 electrons in the L shell. Like this manner we can mark electrons. So totally 8 electrons can accommodate in L shell. So how many electrons will be there in M shell? Similar manner, 2 into 3 square. 3 square is equal to 9. 9 into 2 is equal to 18. So 18 electrons can accumulate in M shell. Similar manner, you calculate with N shell. Okay. So similar manner, we can arrange electrons in an atom and each shell. This arrangement of electrons in an atom is known as its electronic configuration. It's electronic configuration. So from tomorrow's class, we'll learn what are the electronic configuration of different elements. Okay. Thank you.